Hello everyone, welcome to the control system. This is part 7, uh, lecture 7, Transient and Steady State Response Analysis. In this section, we'll discuss transient response analysis with MATLAB. So basically, we can use MATLAB uh, for this. And let's consider the transfer functions given by these equations. And then uh, this system can represent as two array. So each contain coefficient of the polynomial in decreasing powers of s as below. So you can denote the denominators, the numerator as this one, 2s plus 25 like this, 2 and 25, and the denominators, which is this one, 1s squared plus 4s plus 25. Okay, and then if the numerators and the denominators of the closed loop system are known, I mean if we know this one, and in MATLAB you can use this command step and then specify this one and this one, or this one, and you can add t. This will generate the plot of the unit step responses. Well, I'm not gonna do a demonstration for you. I know that you already know how to use MATLAB, so you can try by yourself. Okay, use this command. Okay, next for the control system, which defined in the state space form. So in the state space form is x dot equal ax plus bu by cx plus du. So basically, you know matrix A, B, C, D. In that case, you can use this step, and then you need to have this matrix A, B, C, D, okay, or this. This will generate the plot of the unit step response. Okay, so note that the command step system may also be used to obtain the unit step response for the system as well. Okay, first you can use this one or this one. So in the case it's a transfer function, you need to use this. If it is state space in state space form, please use this one. Okay, and then you can use step and then specify the system here SYS. So let's consider this equation, this state space form. This is matrix A, matrix B, matrix C, and matrix D. With two input, you have U1 and U2. Okay. So how to obtain the unit step response curve? After doing the math, we obtain this GS. Okay. Transform from state space to transfer functions. So you have this GS given by this in S domain. And then, well, this is GS, is a ratio between the output and the input, right? So you have two inputs, U1 and U2. So since the system involves two input, it have two and also two output. Four transfer function may be defined, depend on which signal considers as input and output. So when we consider this is if you consider the signal U as an input, and we need to assume that the signal U2 is 0 and vice versa. So you have four transfer functions. Okay, this is an LTI system, linear time invariant system. You have four transfer functions. Okay. So in MATLAB, you can use this to obtain the step response. Just specify matrix A, B, C, and D. Okay. So in the case of input, there are two inputs. You may need to add additional information here. Please refer to uh, chapter 5 for more detailed explanations. And consider now for the second order system, this is the standard second order system equation given omega n and psi as a comment, and then you can use this comment print by specifying print system by specifying numerator and denominators. We already studied this in the previous lectures. So consider the case where you have omega n equal 5 radian per second and psi equals 0.4, and then you can use MATLAB to generate this GS like this. Specify omega n and then damping coefficient, and then use this command or D2, okay? And specify omega n a damping ratio, and also this 25 times numerator, this one, which is the output of this function. And next, for the unit impulse response of the control system may be also obtained by using any of impulse commands such as impulse, and then specify numerator and denominators. Okay. So these are the command that you should try. Okay. By the way, this is the number of inputs, okay, IU. So like before this, if the input is 2, you should specify that the number of input is 2. Okay, and next, and you can also obtain the response to any arbitrary input by using this lsim command. Okay, like lsim and specify numerator, denominator, RT. R is reference input, and also you can also use this command as well. This will generate the response to input time function R or U. Okay. So in the textbook, the author in this textbook on chapter 5, on the section of on transient response analysis with MATLAB, you will find the detailed explanations and many pseudocode. So please try. Okay, and you need to practice doing it by yourself. Okay, thank you for watching this video.